Alright, yo, back again. Um, as the title suggested, blah blah blah, network signal, model, and SI. I what's the word for it? Anytime I get in a computer class, usually it's the RSI TCP model bullcrap. I usually chunk that crap out of my head because it's utterly stupid. That's bad. In my opinion. That's the main thing I got a problem with right there. Is because I don't put effort into that, especially when it's something I totally disagree with. But right now, as the title suggested, I am going to be talking about network signal, stuff like that. I'm going to try to leave my notes down there in the description because our people in this area try to hack you and, all and stuff. Not that I care, not that if anyone listen. That being said, fun stuff. What was it? Where do we start? Oh, no, fun stuff. All right, so let's start this. A bit for computer wise is more like a electrical signal. You know how there's a positive electrical current output and a negative current output and a neutral current output. Well, in terms of computer, it's more a just positive being one and a low neutral being a zero. Um, and then the frequency, how they change around, and the encoding of the way they change is will be based on the either universal standard every country or that Pacific area or that Pacific program. For the Manchester encoding, think of a rectangle, multiple of them line up together, and each rectangle has a part of the line cut off. Now, imagine those as the Manchester encoding. Imagine the pulses of electrical bits going in, both positive and neutral. At the very low of the signal, where it become neutral, that's zero. And then when the signal get very high, that's one. Then you make about, I don't know, take 8 of these numbers and you have one bit of one section. That's how you get your MAC address, your IP address, your binaries. Basically, it's a binary. And I'm not don't want to go into depth for hexadecimal because that's funny. That's Manchester encoding zeros and ones. I'm going to move on to the next one. I gotta try to make it simple. Now, net signal is more bandwidth. Bandwidth is the speed of data, not much available data you have to pull from it. Download and upload speed is not the bandwidth, wink. It's actually just how fast your area can download and upload at the same time because you need to upload to download. Yeah, that's not how the computer science or network class I'm taking describe it, but that's the best way I can describe it. People viewpoint due to the fact that most ISPs and hackers and stuff just bullcrap the life out of you. Anyway, there are three form of internet network delivery. There's copper cables, there's fiber optic, and there's wireless. Copper cables, as you know, throughout your house and stuff, is electrical signals. They have, if you read a voltmeter and stuff like that, or ampermeter gets your blood pressure and stuff to check out. Yeah, I should not get mine checked out. Check mine out. That signal is the electrical signal. It's copper cable. It's the standard. Originally started with aluminum, then went to copper, and then it went to. At the same time, it went to fiber optics and wireless signal. Fiber optics is a glass that's very clear and sprayed with zinc oxide or copper oxide, or anything that conducts electricity very well, or that has their own formula that does the same thing. That is fiber optic. It's just a glass with signal pulse. Around that glass is a sheet that helps it to produce more of it and bounce the light in, and then around that is another sheet that blocks interference, and then around that is a sheet that protects that, and another that is a sheet that protects that. That's what basically fiber optic. If you write to a diagram, just put two different lights next to each other and have them fade in and out and over. You have light signal. Now, as you know, with electricity and stuff, it's pretty hard. It's either copper, aluminum, iron, and coat around it as the insulator, or you could change it around and coat around it. I'm not gonna get into that in this video. I will in the next one. Wireless signal, on the other hand, there's AM, FM, PM. That's the world standard. Unless you make your own standard like I do. Middle finger. The microwave signal, wireless, travels by point-to-point access, and it still travel in bits as well because it's a wireless signal for the data. You can imagine, just make a squiggly line go up and down, up, down, down, down. PM, then FM, you go up and down, and make a whole bunch of squiggly lines when they go down, make up, then a whole bunch of squiggly lines and go down. AM is more of a it's like PM is just like that. The digital signal is close to Manchester encoding. The 0 is 1. Actually, all of them are. It's just what equipment that is used, what section you get. The fastest form of bandwidth that's available is either coaxial fiber optics. Coaxial is actually a copper signal, but they making a new one. It's just a sheeting around it. Then the fastest regular copper cable will be the Cat 7 or Cat 8. I'm making my own Cat 9. And the heading of that wire will be based on your input, and that will determine the rest of your speed. You know, wireless signal is based on how far you're away from the assets, how close are to you, what equipment you're using, and what service you provide or what service you pay for. I like doing my own virtual private network. I make my own routers and my own modems and stuff, but whatever. Anyway, that's it for this video. I will come up with another one after this. Have fun.